Let's do a short introduction to this framework called Ready, Set, Go, which evolved out of Red Cross's climate action during disasters and its collaboration with the International Research Institute for Climate and Society. I think that's the current name of this center within Columbia University, which has a long history. The pilot experiences in using seamless forecasts for early action starts with a justification of why subseasonal. A forecast creates a window of opportunity for the humanitarian actor, so that's Red Cross speaking for itself, who can use this information to act even before extreme weather events happen. So this is about preparing the funding, preparing the action plans, warning the governments, decision makers, and so on. Humanitarian actors and the governments in low and middle income countries need this time for three main reasons. The more time the humanitarian actor or the community has, the better the preparedness activities can be. Obvious. With an S2S forecast such as for El Nino Southern Oscillation, houses can be strengthened, disaster response units trained, and relief items purchased. A midterm forecast of 7 days, on the other hand, only allows humanitarian action to work on early warning, evacuation, and timely distribution. So if it's a very short lead forecast, then everything becomes about saving lives and minimizing damage and protecting property and so on. But with a longer lead, you can prepare much better to protect more lives and then ensure that even businesses, hospitals, neighborhoods, energy units, grids, etc. can be protected. As the adage says, time is money. Actions can be financed and carried out even before an event occurs. Time also allows for protecting valuable assets in vulnerable areas, as I said, and there is now lots of studies that are mapping vulnerabilities beforehand based on census data that relate family income, employment status, women's education, number of children, access to information, and so on and so forth. Unlike Europe, the United States and Japan, for instance, many low and middle income countries do not have the warning systems or means of deployment to reach out quickly to a city or community to take preventive action. In places with limited personnel and infrastructure, last-minute activities will take days or even weeks to be carried out. So you understand the value of why subseasonal adds a nice window of opportunity to make the whole system much more capable of dealing with disaster relief, disaster prevention, disaster recovery, and so on. We won't go into the details of El Nino, but this is an example of what happens. So typically the warm water that's here and the upwelling that's there gets perturbed during an El Nino, and you can see that there are lots of El Ninos and La Ninas in this period from 1950 to 2018 or so. There are debates about whether there are increased number of El Ninos and so on, but we will leave it there. When the El Nino happens, especially when the El Nino warming is close to the coast in the eastern tropical Pacific, then the Chile-Peru regions get heavily hammered. Obviously, they also lose lots of fisheries, because if you have upwelling suppressed with warm waters, then the nutrient supply, phytoplankton bloom, zooplankton, small fish, big fish, seabirds, everything tend to disappear. So you can see the collapse of the fisheries here in terms of pelagic fish catch in the Southeast Pacific. Lots of nice work done on this by Kenny Broad and his colleagues on how the El Nino forecast information can be used or misused based on who the user is. A bank may do something with it, a fisherman may do something with it, government can do something with it, weather derivatives and so on do something else with it, and so on. Nonetheless, just looking here, we have intense rains in summer, dryness in the Andes region, and so on, because of El Nino. On land, which actually can be really devastating with many deaths, especially when the downpour happens without much warning. You can see the mud here. The man is pouring it out of the window, and that's on the first floor, but you can see cars getting submerged by this river of mud that's coming through. The Ready, Set, Go framework here, we'll revisit this in the next in a chapter later on subseasonal forecast for health. Essentially, it's going to set the system knowing the seasonal risk. So review average risk, average heat risk across seasons. So this is for health, but you can apply it to floods and droughts and El Nino and so on, which in fact was applied in the Peruvian region. Access seasonal forecasts, monitor weather forecasts, update heat action plans, review communication strategies, and so on. We will revisit this later on. In the set step, higher risk in the next month. So monitor weather forecasts closely, recap emergency actions, inform schools, inform cooling centers, reinforce coordination with disaster management personnel, distribute appropriate advice through the media, procure emergency drinking water, because we are talking about a heat wave. And in the go step, you have to prepare utilities for increased power demand. So this is based on seasonal outlook. This is on S2S forecast. This is on numerical weather forecast from short to medium range. So days 1 to 10 or so. Prepare to open cooling centers, begin mass media public awareness campaign, distribute emergency drinking water, and so on. So you understand the idea of combining multiple levels of forecasts, seasonal outlooks to subseasonal, and then weather forecasts. Red Cross together with IRI basically used their experiences to set up a matrix for of the forecast triggers used in Peru, organized by lead time and probability. So probability and impact here is categorized into low, medium and high. Seasonal, so El Nino, the various forecasts. For medium, there is a similar set of forecasts, so it just depends on the confidence level. You can see the numbers go from 2 degrees centigrade to 2.5, go from 10% to 15 and 30 probability, 30% probability of top 10% precipitation, where as in the low probability and impacts, it is 10% probability of extraordinary. So it's not as specific as here, and so on. So based on experience, they have been fine-tuned. In the high probability and impact, the El Nino is much stronger at 3 degrees centigrade. There is 20% probability of extraordinary, 40% probability of top 10% precipitation, and with another forecast, it's 70 to 100% probability of top 20% forecast. So they are not only using different triggers, but they're also using different forecasts based on their experience. So this is kind of fine-tuned for the region. We'll see further details in the next. So there are monthly forecasts with various criteria for low, medium, and high probability and impact. Weekly forecasts similarly, and then they look at sea surface water is warmer, greater than 2 degrees C, and a lot more rain than normal. So community awareness brigades and installation of early warning, wetter than normal, greater than 4 millimeter per day, community awareness and installation of brigades for early warning, and so on. So you get the idea that the system has been, so these are very region specific and impact specific, probability specific, which has been built with empirical experience of using various forecasts. Obviously this is transferable as a framework of Ready, Set, Go, but has to be fine-tuned and calibrated for each region based on whether it's heat wave, mudslides, heavy rains, floods, landslides, and so on and so forth. Okay, wind bursts, whatever. So That's something important. They learned from the 2015-16 El Nino, which was a monster El Nino, well predicted, but the impacts have to be done very regionally. So they created a new pilot trigger for the sub-seasonal forecast. The pilot trigger was written as follows: 1 month lead time with medium probability, sub-seasonal forecast precipitation 1 month, medium percentile 80, mean 80% of climatology, so 6 to 10 millimeter per day. Sub-seasonal early action plan. Here's an example of a triggering forecast. So they have a early action plan in place, and they have forecast-based funding available from banks, so that not much information is required when the forecast is used to demand a loan by a fisherman, by people to strengthen the houses, for the government to prepare for street closures and school closures, transportation, etc., etc. Okay, so what you are seeing here is prognostic precipitation anomaly in millimeters per day for February 26 from NCEP CFSV2. So different initial conditions from 17 January and 18 January of 2016. And you can see they have made it very region specific. So this is for 19. And you can see that the thresholds set are very local. They are not using some blanket threshold for all regions, each region. So here it is dry, here it is wet with much more than normal rainfall, and so on. So with data, with experience, and with reliable forecasts at different time scales, with seasonal outlooks, El Nino forecast comes out several months ahead with various confidence levels. The strong El Ninos can be predicted very reliably 6 to 9 months ahead of time. That scale is almost 0.8. Once that is given, lots of early action plans can go into effect, or at least the ready steps. Then the monthly outlook, seasonal outlook, then S2S at 1 month lead time, and then NWP at a few days, and that can be made very region specific. So this is an excellent example of how S2S forecasts can be applied for dealing with disaster risk reduction by preparations, and disaster management as events are happening, so that is managing the unavoidable, and then disaster recovery as well by planning properly. So these are really growing very fast with specific applications for food, water, energy, and health. So we'll see the health example and monsoon example in the coming chapters.